Well, thank you so much, everybody, for joining. So today we're gonna do a little introductory chat about observability, and hopefully, hopefully that will help you ship code with more confidence. All right, let's do this. A little bit about me. I'm a senior software developer at Shopify. I'm a pet mom. I have 2 cats and a doggy. On my free time, I like to dream about living in the woods, and I'm also a game lover. I love playing video games when I have the time, and I wish I had more time than I actually do it. Cool. Before we start, I actually am curious about what's your relationship with observability today. So I have here a few options, and if you feel comfortable with, and you can share in the chat if you're number 1, 2, or 3. So number 1 is my company or team has observability dashboards and alerts, and I check them periodically, and they directly impact how I do my work. Number 2, my company or team has observability dashboards and alerts, but I'm not very familiar with them, and it doesn't impact how I do my work. Number 3 will be my company or team doesn't have observability dashboards and alerts, or it doesn't have the need for them. Or number 4, if you want to share in the comments if you are in a different scenario. Nice. Thanks for sharing. For those who posted 2 and 3, I think this talk will be perfect for you. And for those who posted 1, I think you still can get some value from that. So hang tight. So why did I decide to do this talk in the first place? So I've been working with development for 13 years, but I feel like I've been coding in the dark because I've always been in scenario 2 or 3 or where my company or team doesn't have observability at all, or it has it, but it doesn't really impact how I do my work. I'm in the checkout extensibility team at Shopify. And earlier this year, I led the backend migration to the new checkout editor. So basically, Shopify, we used to let merchants customize their checkout with Checkout Liquid. But for many reasons, security, performance, we wanted them to customize in a more controlled environment. So we came up with Checkout Extensibility. And so we had to migrate all these millions of merchants to this new platform. And we needed better visibility to ensure that we would have a smooth rollout. And my lights went out. Weird. I don't know why. Anyway, our main concern there was handling a massive increase in requests because we were migrating millions of merchants. And we wanted to ensure that there will be no performance degradation. I saw a question about Liquid. No more Liquid on checkout. I think there's still Liquid in other areas of Shopify. Yeah, so we implemented metrics, dashboards, and we did, in fact, found the issue during the rollout, but it was related to a separate team because we had dashboards, the alerts. We were able to identify this earlier and address with the team. They made a few tweaks, and there was no performance degradation, no issues. The release was a success, and yeah, it was really good thing. But maybe you're here because you don't even know what observability means. So observability, if you don't know what observability means, it's a term that we use to describe the ability to understand the internal state of a system by examining its external signals. What are the signals? So there's logs. Logs are text records that you can see how the application is doing. When you run Rails server, you immediately see logs there. But some companies also have a production application where you can see the logs. There's metrics. Metrics are numeric data points that you can use to track things such as like CPU usage, memory consumption, request rates, and even custom things like features and anything really that you want to track when it goes to production. And we also have traces. Traces are detailed records of an entire journey of a request. And as you flow through the different services and components, so it helps you figure it out, like possible issues or delays in specific spans of the request journey. And profiling was only introduced to OpenTelemetry and Observability earlier this year, and it allows you to inspect the code behavior and performance at runtime in production. So pretty cool. A few use cases for observability in production is understand the impact of new code changes, quick problem detection, improve the system understanding, track health and performance, enhance the user experience, which can be related to performance as well, and scalability and reliability. So basically, not only you're there coding on your own development machine, fixing bugs, but you're owning the changes from development to production and ensuring like that the system is reliable. There are here a few commercial tools. There's Datadog, New Relic, Honey Badger, Signal, Rollbar, Splunk, Sentry, Scout, and many, many others. Some of them are more focused about logging or traces or metrics or like a combination of all these things. Yeah, I'm curious if you feel comfortable sharing, like, do you use any of those tools at work or for personal projects? Feel free to share in the comments if you feel comfortable. Yeah, I used New Relic in the past, Honey Badger, Rollbar, Splunk, and Datadog, like in companies that I worked for. And I used Sentry for personal projects, and I really liked Sentry. Nice. Yeah, Datadog and Sentry and New Relic are very, very popular. Thanks for sharing. That's really insightful. We also have open source tools. So there's Prometheus, more focused on metrics, Fluentd for logging, Jaeger for tracing. Grafana is like a UI that you can see a bunch of things together. So you can create dashboards and manage alerts, and it does a bunch of things. I don't think it's only related to observability, but it's very commonly used with Prometheus. And OpenTelemetry, which is not a tool, but it's an open source framework. I have a separate slide for it. Does anyone here use one of those open source tools? Feel free to share. Nice, good question. I will share more about this open source tools during the talk. Nice. Yeah, I'm going to cover lots of Prometheus and Grafana in a more like introductory way, but yeah, cool. Let's talk a little bit about OpenTelemetry. So OpenTelemetry, it's an open source framework or toolkit that it's used to manage telemetry data, so logs, metrics, traces, and now profiling. It integrates with many tools, so Prometheus, Grafana, Datadog, New Relic, and it has been becoming very, very popular due to the standardization that it does. So let's say your company uses Datadog, but the bill's getting too expensive, so you want to switch to an open source tool and then own your data, and you have an infrastructure team to deal with that. Supposedly, it's supposed to be easy to switch from Datadog to Prometheus and Grafana or other open source tools if they use this standard. Cool. I have a demo later in this presentation, and so a few things I'm going to mention here is so that on the demo you don't feel lost. It will help you understand things a little bit better. So we're going to talk a little bit about Prometheus. Just a reminder, it's an open source tool. It's used mostly for metrics and also alerts. So Prometheus has 4 different metric types. You have counter. Counter is more to count occurrence of events. Can be used to count number of requests or errors. We have gauge. Gauge is more used for measurements that fluctuate. So temperature, maybe number of open database connections. Histogram is very interesting one. It samples observations and counts them in configurable buckets. It's usually used for request duration, response sizes, and lastly, we have summary, which is very similar to histogram, but it does a little bit more. It also provides us with the count and a total count and sum of the observed values and the quantiles that we're going to see more about it later. Also used for request durations, response sizes, things like that. Cool. Prometheus has a query language called PromPL. It allows you to query metrics, aggregate data, sums, average rates, and visualize trends. Here's an example. This is a query using PromPL. It's getting the rate of the Ruby HTTP request total on the controller jokes using this rate interval that I'm pretty sure is from Grafana. And it's aggregating by the status. And so with this query, we would expect to see something like this. We see 2 results grouped by the HTTP status. And then you can take some insights, like between 210, 220, the number of errors, responses that return 500 are bigger than the 200. So something must have go wrong here, right? And I want to mention another thing about PromQL and Prometheus, because when I started learning about it, it was driving me crazy that I couldn't get exact numbers on my graphs, and now I understand why. So I want to share with you in case you want to work with Prometheus, and so you don't go to the same trouble that I was having. So the way Prometheus works, it takes snapshots of data at regular intervals, and events between these snapshots may not be captured exactly because of the intervals. So we use rates to smooth out the trends. And there's an example of how to get a rate over there on the interval of 5 minutes. And then you might not see the exact number. Maybe you're testing locally and you only have a few requests. Like you send few occurrences of a metric and you expect to see the exact number. You'll see something very, very similar to what you expect, but not the exact number. Still pretty useful though. Let's talk a little bit about SLIs, SLOs, and SLAs. They help the company or team to understand and quantify the reliability and performance of the services. Okay, but what the hell is that? SLIs are service level indicators, so the actual measurement of a system. SLOs are target or service level objectives. They are targets for the SLIs, so targets for the metrics. And SLAs are service level agreements, and it's like a formal commitment that the company has with the customers. I'm gonna give you an example and then it should be more clear. I found out that GitHub actually have public SLAs, which is pretty cool. It says that GitHub commits to maintain at least 99.9% uptime for services, and failing to this criteria means that a credit claim can be made by customer. I didn't know that. I thought it was pretty cool. So next time you see that angry unicorn there, maybe you can do a credit claim. So that's a public SLA. It exists. And this is a fake SLO, just to give you an example. Maybe in order for GitHub to ensure this SLA doesn't fail, they could have an SLO for uptime for actions, which is one of their services. The SLO usually will be slightly bigger than the SLA because you want to be conservative. You want to be alerted before the SLA actually fails. In order to measure this goal, maybe you could have an SLI for total triggered executions and another one for unavailable executions, and then crossing this data could get you to have like an SLO that will prevent the SLA to fail. Another example of an SLO could be 99.99% uptime for issues and pull requests as another service. And then maybe an SLA for that could be the service availability crossed with the error rate. And then you cross this information, you calculate your goal, and then you have your SLO, your SLI, and your SLA. About SLOs still, let's talk a little bit about percentiles. I've always seen like people talking about P90, P50, P99, and I'm like, I don't know what that means, but I'll go with it. Let's get some clarity about that. So P50 will be like the average, will be like the average rate of something. So let's say the P50 of one request is 1 second. It means that 50% of the requests are actually faster than that, and the other 50% are slower. So it's the average user experience. P95, however, will be the typical worst case for performance. So it means that 99% of the requests are faster than that, but that's the typical worst case scenario for users. And it means that 5% of the users are getting performance that's worse than that. So if it's 2 seconds, it means that 5% of the users are having a performance that's actually higher than 2 seconds. And P99 is usually used for rare performance issues. So it means that 1% that's getting like the worst performance ever. So if P99 it's 3 seconds, there's 1% of the users that are having like really bad performance issues on their application. Cool. None of the things that we saw so far matters at all if we don't have alerts. Because you can have beautiful dashboards and metrics, but if nobody looks at it when there's a real issue, it's worth nothing. So let's talk a little bit more about that. You can create alerts based on your SLIs and SLOs and use them to warn the team when the application isn't working as expected. Most monitoring tools will let you configure alerts. But be careful not to introduce noisy alerts, because if you have an alert that's going off all the time and it's not a real issue, there's this weird thing that happens to our brain where it creates a pattern and people start to ignore it, and it's nobody's fault. It's just like something that you need to be very careful about, not to create noisy alerts. Same goes for exceptions. And lastly, alerts must be actionable. I'm going to talk more about that. One thing that you can do in order to make the alerts more accessible and actionable is to have a playbook. The playbook could be a documentation that goes on the company like internal documentation system, or it could go in the alert description itself, or even better, could be both. So in the playbook or the alert description or both, you should describe what to do when the alert's triggered and also what to do when there are false positives, false alerts. Again, we want to avoid noisy alerts. my suggestion here for another description is to have a very specific title, describe how the alert's being calculated, because you don't want to go on vacation and then the alert goes off and then nobody understands why and if it's a real problem or not. You want to describe why the alert may go off, what to do when the alert goes off, including what to do when the alert goes off by mistake, when it's not a real issue, because again, I'm going to be talking about this many times, so we don't want noisy. And another cool thing to add is the customer impact. I have an example here. I hope it's readable, but I will also read it. So the title here is very specific. It says backend errors. Jokes API custom error monitor have received more errors than normal. The amount of errors on the backend for Jokes API has exceeded the threshold of 0.1% because it's now in 0.2%. How do we calculate this metric? We are using the percentile of P50, because here we just care about the average impact. This monitor may go off because then here I added whatever I could think about that could cause this error. So I added, we are using an external API and the API might be down. The version of the API might have changed, or the code that consumes data from the API might be broken. How to fix it? So the first thing is investigate what's going on. So if you post a Jokes API custom error on the logs platform, it might give you an idea of why the error is happening. And then there is also an instruction here saying that if the alert's going off too often with false positives, to consider handling it in a different way or increase the threshold, because maybe there is a known issue, the team doesn't have time to work on it. It's better to increase the threshold of 0.1% to, let's say, 0.3, and then get alerted when it goes to 0.4, than let the alert pop all the time and it gets ignored when things go off rails. And then lastly here, we have the impact. So customers could have been problem accessing the index page, which is really bad. So if you put the impact there, maybe the person who sees the alert might, take action faster. Awesome. Now I'm gonna do something wild and I'm gonna try a live demo. I hope it goes well. For this live demo, I'm using this Rails project here. I'm gonna share the slides later, so you can access the links. And I'm gonna be covering metrics. And I'm going to be using Prometheus and Grafana to collect and visualize metrics. And I'm using this gem called Prometheus Exporter to export the metrics from the Rails app. Cool. So this is how my application looks like. Nothing fancy. It's fetching a joke from a public jokes API. When I refresh, it's going to fetch a new joke and then a new joke. This joke doesn't have a title. Some of them have a title. Why do we care? We don't, but I have a custom metric for that, so I'm going to show you later. We have a dashboard here. So this is how Grafana looks like. In the back end, I see the jokes were good, I hope. So I got some bad ones that I was a little bit concerned about refreshing the page, because who knows what's going to show up there. Cool. Let me look here. So this is how Grafana looks like. And the backend, there is Prometheus and Prometheus Exporter, exporting metrics to Prometheus. We have here a board with the average request duration. We have P99, P90, and P50. As we can see here, P50 is around 300 milliseconds, P90 about 300 milliseconds as well, P99 almost 400 milliseconds. So it's not bad. It's actually a good performance for this purpose. Have another one here that it's the rate of HTTP requests grouped by status code. So here we have 500. We've been having 500 requests, which is great. And here are like all the 200. So mostly we're getting 200. So mostly the microcontroller is succeeding. Cool. I have a script here that's pinging my application every half a second. And this is my controller. I'm gonna uncomment this code here, and I'm gonna simulate like if the API would time out. So I'm adding a sleep time of 2 seconds and pretend that the API is timing out. And then we should see, sorry,
just real quick. I don't think we see the code. We only see the Grafana dashboard. Yeah.
Oh, sorry. I think I need to share the screen again. Sorry about that. Thanks for the heads up. Oh, I should have selected the entire screen instead. Okay, I'm gonna go back to the code here. I have I was showing that I have a script here that's pinging the request every half a second. And I have, this is my controller. I'm fetching from this public API, and there is a sleep time here that every 20% of the time you should generate errors. As you can see here, we're getting a couple of 500. And now what we're going to do is see how a timeout error in my controller can impact the graphs. Here we can see that the number of 500 requests are increasing, as well as the number of 200 requests are decreasing. The P99 already went all the way up, saying that's taking over 2 seconds to complete requests for 1% of the users. And the P90 should go up too, because you're raising errors for 20% of the users, but that takes a little bit longer. Okay. The other thing I want to show you is that I have an alert here. Right now it's normal. And it says that when my jokes page P50 is over 2 seconds, it will notify me on Slack. For example, if I don't really have it set up to notify me, but it will go red. Cool. Yeah, P95 went up. Let's make it so the timeout occur for 80% of the users. And for this, we will have to wait a minute or two. In the meantime, I'm going to show you some extra stuff. Hope I'm not going too fast. I have a separate dashboard here, separate graph, because I was curious, how many of those jokes have a title or not? Because one time I was refreshing it all the time, and most of the jokes didn't have a title. So I thought maybe most of the jokes doesn't have a title, but I actually, surprisingly, it's kind of half-half. And you can see here that sometimes most of them doesn't have a title, but some other times most of them do have a title. And I don't know, this is an example of something you can track custom for some feature in your application. Okay, the 500 is going up, but the P50 is still stable. Didn't get enough errors. I'm going to show a little bit of code in the meantime. So I have Prometheus exporter here as an initializer. I'm just adding the middleware, and it handles everything else. But I do have to run it as a separate server. And then here I have Prometheus YAML. And what I'm saying is that this is the endpoint for Prometheus exporter. I'm telling Prometheus to scrape metrics from Prometheus exporter on this port. And then I go back here. I have my custom metric. It's a counter metric. The name is jokes custom metric, and it tells me whether a joke has a title. So joke title present, it's going to be true, otherwise it's going to be false. And here, this is the endpoint where Prometheus collects the metrics. So you can see my custom metric here, the counter for the ones that had title or not. We can see the summary metric for ATP request duration. It creates that for every controller. I only have one controller here. And he also creates the quantiles that I can use for my P50s, P90s, and etc. If I go back here, now something really bad's going on, right? The P50, it's taking over 2 seconds. But luckily, our team is aware of it because we're getting an alert on Slack, and everybody it's taking an action, has their eyes on it. And we heard from observability and not from the customers, which is the main take of this presentation. Let's go back to the presentation, and we're almost wrapping up here. I do want to invite folks for a reflection, maybe even homework. So my question is, do you have observability implemented? If yes, when was the last time the observability helped you find a bug? Was there a recent incident that observability could have caught? And yeah, this is a great opportunity for you to introduce some alerts and maybe some metrics too. And remember that they have to be actionable, the alerts. And if you don't have observability at all, then why not try to implement one of those tools that I mentioned on this talk? However, if you're just a dev, if you don't want a full-time job, taking care of all the infrastructure for Prometheus and Grafana and the open source tools, I recommend going to one of the commercial tools. Most of them have like free trials and free accounts that you can start with and sell the idea to your team and your company. And yeah, it should really pay off with time. And last question, does your team have a playbook? Maybe create a playbook, list all the alerts there, all the metrics, what's the intent, what to do when the alerts are going off too often, and things like that. And all of these things, they're really valuable to the company. So if you see opportunity to work on some of these items, it should help your career, hopefully, maybe even a promotion that you're working on. So yeah, keep that in mind. It's a great opportunity. And that's it. We're done. That I have there my email and my website if you want to reach out. My website has all the social media. I would love to keep in touch. So feel free to give me a follow and send a message. And I have some references here too. I'm going to share the slides later so you can access the links. We're good.